We're now here to resume the second session of the seminar, and there has been a change in our agenda. Unfortunately, Dr. Ted Johnson from AT&T Laboratories has just informed us that he will be unable to attend. Well, his work has produced a lot of interest by the senior officials of this company, and he has been asked to have his talks authorized, and apparently the authorization has not yet arrived. This is why he just informed us that he was going to be unable to give his lecture today. I was asked to send his apologies, to convey his apologies, and we are now at the seminar that we were fortunate to have been charged with by INEGI. Personally, I thank the authorities of Infotech for their willingness and support to organize this event. I believe this is a subject of strategic importance, and that is also very current subject. I had the opportunity to attend an event in San Diego with Dr. Garcia Nocetti, and one of the participants said that big data is a subject such as sex amongst teenagers. Everybody talks about it, everybody says that they have already done it, but nobody has really done it. And well, we are precisely in this wave that is coming, because large companies such as Google and Amazon have been promoting this topic, trying to put in place a new order in the arena of new technologies and of our daily living. At times, progress in terms of technology does not affect us on day-to-day matters. This is one of the disruptive technologies that we are being affected by, even if we do not realize it. So now going fully into the agenda, we're honored to have with us Dr. José Alberto Incera Dieguez. Dr. José Alberto Incera studied engineering in electronics with a specialty in digital systems at the Autonomous Metropolitan University Escaposalco. He then carried out a master's on computing science, specialized on computer architecture in the Imperial College of Science, Technology and Medicine in London, England, as well as his PhD in informatics at the University of Rennes 1 in France. In the assessment of computing networks, he is currently director of the Masters of Information Technology and Administration at ITAM. It is also worthwhile mentioning that Dr. José Incera received a very important award by IBM, the Big Data and Analytics Faculty Award, which recognizes his work in the development of projects and on big data, as well as his contribution in the education of students able to analyze large amounts of information strategically, also to be developers of big data as well as business analysts. So without further ado, we will welcome Dr. José Alberto Incera Dieguez. Hello and good afternoon. I am a bit embarrassed when this long resume has just been read, because I am unable to start up my own computer. So let me find out if the presentation is already being displayed. I would like to thank Infotech and INEGI, and congratulations for preparing an event such as this one. I am also somewhat intimidated by having to give this talk at this time because the presentations this morning were extraordinary. So this presentation is about how difficult it has been for us, at least at ITAM, to raise awareness and to draw the talent that is needed to detonate in innovation initiatives on big data and analytics. Jose Luis Morales, my colleague, is around here and he will be discussing this from the standpoint of data science. I am mostly responsible with infrastructure for the implementation of big data projects, and just now, a couple of years after beginning with this sort of initiatives, we started to see a demand that was much more pressing and immediate from organizations and companies in Mexico to start working on these areas. So congratulations, and hopefully this will be an event that will help us to trigger and do the very necessary leapfrogging that is needed in these areas. So the subject that was invited to present today has to do with two aspects that were discussed this morning. Javier Puyol, Justice Puyol, was discussing intelligent cities, the Internet of Things, how this the technologies will enable us to have more efficient services for the citizenry, and how this will help us to fight climate change, environmental pollution, as well as a series of relevant elements for contemporary society. During the first talk this morning, we saw that two of the most important challenges to deploy these type of technologies have to do with the development of human capital and the infrastructure management in order to work with these technologies. So what I will be presenting today is a concept test that we did. We took it as a case of study, was a pretext. It is the environmental monitoring system of Mexico City, and we had two main objectives with this. First, to create knowledge and to raise an awareness in our students regarding the adoption of wireless sensor networks as well as big data, and eventually in that path of learning, we would assess its feasibility for it to be deployed at a citywide level. I'm gonna skip the obvious parts about big data. You will be hearing a lot about this, probably too much about big data during this seminar. Regarding wireless sensor networks, it is one of the main inputs for big data technologies. And the final session this morning, a question was asked: what does text processing have to do with big data? Well, it is a fundamental component, because big data is structured, unstructured, semi-structured data alongside the volumes and the speed with which it is generated. And such as we have a lot of elements of unstructured text that we need to make sense of, then we will also have a phenomenally large amount of technological components, sensors that will be incorporated to the cloud, to the web, and that need to be properly assessed for proper decision making, and that is what this is about. So it will be one of the main actors of the Internet of Objects. This is somewhat cliched. This is somewhat something we've heard a lot about. This is an image of the environmental sensor network that is also used, for example, for crop monitoring, for environmental pollution monitoring, and a lot of other components that are not added. And this diagram is for the sake of simplicity. But now these are the expectations that Cisco just highlighted in its last study, the Visual Network Index, and these are in blue. We have the number of humans that currently live in the world. The red line is the number of people that are connected, and in green have the number of devices connected to the internet. These devices produce data, and these devices need to be integrated and processed with the technologies that we use to make sense out of the information they will be producing. So we go from the Homo connexus to the Que connexus, and now big data has several the ways of describing it in terms of volume, speed, and variety. Alejandro Quisante's explanation this morning was very good. We call big data all that information that cannot be processed with conventional technologies in an efficient manner, and there we find enormous opportunities for what my colleague Fabian Nocetti will discuss much more properly. Now we have the world of sensor grids. I call them wireless sensor grids, and that's actually a mistake because we're actually talking about of any type of sensor grids that will be exploited for their data, the data they produce. The idea is to bring together big data technologies with possible sensor grid networks. And CIMAT, the environmental monitoring system of Mexico City, is what we took as our case of study because it is for us a classic example of what open data of, uh, of data that should be available for researchers and for citizens, and how this might also enrich decision making at the short term. It is constituted by four systems: RAMA, the automatic network of environmental monitoring. It is there where we are focusing our study. There is the manual network of environmental monitoring, the atmospheric deposit network, and the meteorological and the solar radiation network. This is what helps us determine if kids are allowed to do sports activities outdoors and so on. And part of the problems of these networks, there are a lot of historical reasons why this network has a very well, several problems. And it has to do with the very low granularity of this network. In Mexico City, we only have 16 nodes, 8 on the surrounding areas of Mexico City. Not all municipalities are covered, not all the boroughs of Mexico City are covered, and the granularity, the very low granularity with which this data is produced within CIMAT to the outside is very low. This is why we're told that we have a very low level of pollution in the center of the city. But beyond that, there is not so much information about what we might do or how risky it would be. So this network could very simply and be extended with a network with a grid of lower cost sensors at a lower cost that a serious monitoring station would require, and all these sensors would be able to provide for us with well, much more faster and much more accurately what is actually going on with the dispersion of pollutants and and a specific site, a specific population area, at a specific municipality, what is going on with this. So the idea in the long run would be having a set of sensors, and these would be grouped in clusters, and in these clusters we would have the infrastructure, the big data infrastructure, in order to analyze the information that these networks are deploying. It is a concept test, so please do not take this very seriously. But with Arduino technologies, with wireless sensors, here we have a CO2 sensor, a ozone sensor. We also have temperature and pressure, as well as moisture sensors. This gizmo here is worth less than $100, and it is not commercially produced. Multiplied by any number you wish, and it is less expensive than any other thing that is manufactured at a production level. This could be mounted on public lighting poles. This could have any necessary protection capacities to supplement the information that is currently being produced. And this is just one example of the use of sensor arrays for purposes of, well, for the use of citizens. This is the data acquisition module. These are sensors clustered in gateways. This would go through the MOM, message-oriented middleware, way in which we break synchronization between one component and the other. And the important part of this, the actual goal of this seminar, has to do with the data processing module. We could have hundreds of thousands of these sensors working with gateways that are producing very fine-tuned data in terms of time that would then be sent to the processing module. This processing module is cut in half. There is a processing component that enables real-time or near real-time processing for warning processing, when the thresholds that might compromise the health or the safety of the city are exceeded, and then a more conventional big data module intended for more sophisticated types of statistics, correlation analysis, predictive analysis, and any other type of studies that are a lot more related with the area of specialty that most of you represent. Now I'm going to skip this slide about the important component of the data processing module. As I said before, I am embarrassed that I do not know how to use this technology, the pointer. But well, this is for queue management. I have the component of data analysis or the first tier data analysis. For stream processing, we're using Strom of Fortis. There's also a series of auxiliary databases to facilitate the operation and analysis of the information that is being generated. Whatever is generated throughout the day is then stored in a server that is then sent to an environment that can create non-real-time statistics, but that are a lot more sophisticated as analysts require. And what we do produce with the immediate result of first-level statistical tests is stored in a conventional database, MySQL, with which we can create heat maps and things of the sort.
The newest aspect of the different components here have to do with the stream processing component. We've worked with two different technologies, first with streams of IBM and with Storm technology, which was independent and fundamentally is used by Twitter for most of its trending topics and such. So since the AT&T speech was interrupted, well, I had to change this a bit. Here you can see where the facilities or the possibilities of the technology is. This was taken from IBM, but stream computing was an old idea. It was forgotten. Now it's being recovered. Here on the far left, we have data sources which are being generated. The data of the components that are relevant to this. There we have the sensors, and eventually they are fed through modules. They're called spouts in the modules. They are the chains, the input chains, and they generate the green things which are called duplas. And so we have real-time processing. Each of the red palettes is collaborating in the objective of the researcher in order to identify the needs. So the same with Samba streams, etc., and all the technologies we have for stream computing is that they can be agglomerated in order to scale and replicate and ensure the availability of the resource as design may require. The modules here are grouped in blue boxes, which eventually, this was not me, I think. So these boxes here can represent a server, a processing server, so we don't overload our computers. They may have replication to ensure availability, or they may have other modularity element that complies with the elements of the project in itself. Specifically for our project, this is a topology. Here we have the spouts, and here we have sensor statistics in a gateway and at the level of the base station, which is grouping what we would call the clusters. These statistics are very simple. Well, the ones done by the stream processing network, and we have statistics that are a bit more sophisticated when we store this in the Hadoop and the other model which is behind this. So an important point of consideration here, because some questions had been asked on how do I enter the world of big data and how do I manage these tools? Well, one of the speakers said that we would have to take a topic which is relatively controlled. We need to be familiar with it. We need to control these tools adequately, and then this is little by little scaled. And one of the things that we will face, or something that we normally face in the small projects on which we work is where are the data sources. They're not always there. However, we need to work with the technologies and we need to become familiar with them and dimension them, and we need to do everything we need to do for the life cycle of the data. So what we do is that we take from the real source, which are the Arduino's sensors, the characteristics of the data that will be fed to our stream processing network and Hadoop. And once we know this and we know the variation parameters, we generate a simulator which replicates what thousands or millions of generators would be doing to feed big data. So this is what we did here. In our first chart, you can see what the volume of traffic is that generated by a small sensor with 4 parameters only, and if this were used with a 2.5-minute granularity for measurement, we would have, in the case of our test scenarios, 82 substations, which is actually a very small network. We would have 576 samples a day, but this would allow, this would be 335 gigabytes per year. And if this is thousands, well, it becomes easily more than 1 petabyte. So to feed our simulator, the part on big data, well, we have statistics on how to more or less historically disperse pollutants according to what the CIMA has shown us. And these are just distribution functions for the random number generators, and they begin injecting readings which would be equivalent to sensors of our network. These are eventually put here. We worked with a large bank of experiments. Well, our objective was to ensure the technical feasibility of the project. A lot of it had to do with learning and training the human capital working with us. The tests in themselves, or the results of these tests, are quite irrelevant, but we were able to detect atypical events and to send SMS alert systems. We are also able to create heat maps, which are not here for this presentation. We could also see this behavior, compare it with historical data, and see if there was any change in the parameter of temperature measurement, etc. So the area in itself of knowledge in which we're applying these technologies, well, we'll just leave this to the experts, to the environmentalists, meteorologists, chemists, but the technical feasibility and the possibility of actually working with these technologies is what resulted most valuable for us. On the project itself, we used a series of technologies that at their moment were relatively new and unknown. The learning curve was much lower than expected. The only place in which we one way or another had a setback was in relearning aspects of stream processing, understanding this in distributed real time, and this is a bit distant from what we normally do, but working with Hadoop, having a distributed system and integrating this system through message queues, well, who has good databases of software engineering, well, that whoever has them is going to be able to solve this quite easily. At the production level, this would be much more complicated, but this is where the cloud comes into play, and the AWS and other things are currently available. So this problem isn't such a problem itself, and this is, well, okay, now solving the problem and creating an algorithm. Well, what we did prove in this experiment, because there is a huge variety in technological possibilities, is the economic feasibility. And it's hard to justify economic feasibility because, first of all, the infrastructure and the complexity algorithmically of this infrastructure has to do with the problem you're trying to solve. Second, because there are more and more offers, more and more options to use these types of technologies. And third, because the relevant part for this project in particular has to do with having sensor systems that are tolerant to hostile environmental conditions, and this is very far away from what we currently have. With regards to this seminar, two things that we think are very important are the following. It's not enough to have a open policy or to have a disposition that has to do with the cultural change to access data. The CIMAT, as many other dependencies, do offer open data, but they do so at the end of the month, and they do so with very low granularity. They are grouped by hour. They only have averages. They have maximums, minimums, but they are also given to you in Excel, not as a dashboard with a control, as a dashboard with some indicators of how the pollutants are behaving. And I think it's super important if we pay attention to any of the conclusions of this morning that these open data strategies and official data which can be incorporated to having better governments and innovation opportunities and incorporating developers in the original use. Having access to data is not enough. We would have to have access to APIs, and this would imply looking at our institutions not as data suppliers of a certain quality, but as suppliers of business processes because they could be incorporated. The fact that we get data at the end of the month is better than nothing, but the best we can do is understand the history of the data. And if we want to have alternate services to the ones that an organism such as the CIMAT has, according to its mandate, we need to have access to data in a much more swift, efficient, and transparent way. And I think this is what we haven't seen in this discussion, and I think that's what's most important in detonating opportunities. Thank you. We thank the presentation by Dr. José Alberto Incera. I think what Theodore Johnson was going to speak of was this part of big data, which is big data streaming, and which, as Dr. Incera has mentioned, faces challenges which are different to what analyzing data that's already available and which are being generated in real time. I think the issue in the conclusions on the fact that institutions need to be ready to have this openness and showing their data in a timely fashion, well, it's relevant.